Okay, so hello and welcome to this video tutorial for A-level mechanics. So we have this problem from the June 2023 paper. It says at time t seconds, where t is greater than or equal to 0, a particle p has velocity v meters per second, where, and then v is given as a function of time here. First of all, we're being asked to describe the speed of the particle p at time t equals 0. Well, since we're given its velocity as a function of time, we can just substitute in our value of t equals 0 here. So we could say v at t equals 0 here is equal to 7i minus 3j. Is that our answer? No. This is where we can bring in this idea. Since we're being asked for the speed of our particle here, note that velocity and speed are two different things. This is a velocity. Speed, on the other hand, is just a number. So, and speed can kind of be taken as the magnitude of velocity. So in this context, to find the magnitude here, we can use Pythagoras' theorem. I'm going to describe speed with s here. I'm going to say s at t equals 0 is equal to 7 squared plus 3 squared, or the square root of 7 squared plus 3 squared, which is going to be the root of 58. We can decimalize that to 7.62. It's not really necessary, but there it is. Okay, part B then. So part B is asking the value of t when p is moving parallel to I plus j. So you can imagine I plus j, right? I plus j is moving just as much across as it is up. So it would look something like that, like a 45-degree angle. The idea really is that the I coefficient is equal to the j coefficient when p is moving parallel to I plus j. Since we're saying at that point, this is equal to this, well, let's just write that out. We can say here that t squared minus 3t plus 7 is equal to 2t squared minus 3. And you'll note this is a solvable quadratic equation here. Let's subtract 2t squared from both sides, so that's going to give minus t squared, and let's add 3 to both sides. So that gives us this. We've equated this to 0 here, as is kind of standard for solving quadratics. I've just multiplied both sides by 1 there, and I trust that you guys are familiar with factorizing quadratics. We're looking for something that multiplies to give minus 10 here, and that adds together, or that add together to give plus 3. You can get 5 minus 2, can't you? So we have t plus 5 multiplied by t minus 2 is equal to 0. Therefore, we have one value of t of minus 5 and another value of t of 2. Now, since t is greater than or equal to 0, as stated in the problem here, we can say that t is equal to 2 here. Okay, cool. And that's the answer to our part B by the looks of it. Let's move on to part C then. It states the acceleration is asking for the acceleration of p at time t seconds. So this is where we can introduce this idea that I've shown in the bottom right here. If you were asked to define acceleration to someone, what would you say? You'd probably say something like acceleration is the change in velocity over the change in time, or change in velocity per unit time. And this is what this is essentially describing here, that a is equal to the time derivative of velocity. So we have an equation, we have an equation here for velocity. If we differentiate it with respect to time, we'll be left with a function of acceleration with respect to time. I trust that you guys understand this. So let's go ahead and differentiate this then. So we can say dv over dt is equal to 2t minus 3 I plus 4tj. So just write it out like that. So this is a function of acceleration with respect to time here. We're looking for the acceleration of p at time t seconds. Well, there we have it. Okay, this is our acceleration of the particle p at time t equals t. Let's move on to part D then. So part D here, we're being asked the value of t when the direction of the acceleration of p is perpendicular to I. So perpendicular to I, note that I, or the kind of I-axis, is our kind of horizontal axis. If the acceleration is acting perpendicular to I, then naturally it's acting up, right? It's acting vertically, up or down, really. If it's going up or down, we can assume then that there's no horizontal component there. It's only either acting up or down. So this is the point essentially where the I coefficient takes a value of 0, since there's no horizontal component at that point in time. So we could say then at that point 2t minus 3 is equal to 0. Therefore t is equal to 3/2, which is equal to 1.5 seconds. And there we have it. These are all the solutions we have to our problems here. 7.26. I should describe that as meters per second. Time t equals 2 seconds there. We have this vector for acceleration here, and we have time of 1.5 seconds. If you have any questions or comments about this problem, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.